Writing tests? Then you probably need to mock. In this episode, I talked to Artem Zakharchenko, the creator of the popular mock service worker library. We discuss common mocking mistakes, how to find mocking boundaries, the distinctions between different types of testing, techniques for generating mock data, how to find a balance between unit, integration, and end-to-end tests, and much more. All right, so Artem, I have been excited to talk to you for a long time because I've been using Mock Service Worker and really enjoying it. And then this morning I was having fun working through your course because you were kind enough to let me have access to it recently. So I've been enjoying that too. And so in this conversation, I think our primary goal is to really chat about mocking. And mocking is something that I find trips up a lot of developers. So to kick this off, I guess let's just start then. When you think about mocking, what have you found are the most common mistakes that people make related to mocking?
I think, from the top of my head, probably the biggest mistake is when people mock too much. You don't have to go far. Let's take a look at MSW. It exists because people used to mock too much of their request clients. So they replaced, let's say, the fetch function. And suddenly they're throwing away a lot of useful things that they need to run in tests as well. So this is a very common problem. And it goes beyond API mocking. You can mock, your database client in a similar way. Perhaps it comes down to where you draw this line. So a lot of people draw this test boundary, what I like to call, quite high, and they remove a lot of useful code in the process. And that's a huge mistake because you want the tests to still resemble how they run in production. So you still want that database client to run their logic behind the scenes. You want that request client to do, payload normalization, request validation, and so forth. But if you mock it way too much, you're losing all that. So you're still in control, of course. That's what mocking gives you. But you're drawing this line way too, drastically. If you
I like that. What you're pointing out is also a mistake that I see more broadly in tests, which is somebody writes a test and it doesn't actually test anything at all. And when we talk about mocking, that is the risk. If somebody ends up mocking to the point that now the very implementation that we were trying to test is no longer under test. So how does someone avoid making that sort of mistake?
I think it comes down to two things. So first, you need to have a clear understanding what you want to mock, because sometimes it's not as straightforward. It's okay. We all been there. We've done these mistakes, but sometimes people don't actually need to mock what they're mocking. Like if you want to have control over certain behaviors, sometimes that's exactly what you want to have. So again, speaking of network, you can just mock the network itself. You can keep the request clients and obviously your app, your tested code intact. Mm-hmm. So that's one thing to keep in mind. Understand what you need to mock. And then the second thing comes down to tooling. So sometimes even if you have a really clear idea, okay, I want to mock this thing, there used to be the time where we didn't have nice tools to do that, where we just had very, very aggressive mocks that just replaced entire functions or entire modules. And I'm very happy that this is kind of solved now. We have a lot of really nice tools. We have mocking built in frameworks like Vitest. And I think even Playwright also ships with some network mocking capabilities. So I think the tools have evolved, and it's really important so people also have better understanding of how they can use those tools.
Yeah, absolutely. I really liked at the beginning of your course, you've got this little tool that, actually it's a website, and I can't remember the name of it. Remind me the URL.
It's
where I can
howmocking.works.
That's it. Yeah. Howmocking.works. So the .works is actually the domain, which nice work there. So you go to that site, and for those that are just listening to the show here, what it is a visualization of I've got a dependency, and it has another dependency, and it has another dependency. So you've got A, B, and C, and I can go in and click to toggle off a given dependency, and effectively at that point I am mocking that dependency. But this is a visualization that's helpful because the mistake that people can make with mocking is either not mocking enough or mocking too much. And so I really like that in your course, you make this point of saying, when you're thinking about mocking, you need to have real clarity about when should this test fail? What is the system under test here? So the mistake that we can often make is you mock one too far and now you're actually not testing anything. But then on the other side, if I don't mock enough, then I don't have determinism. For instance, if HTTP calls are occurring, then, well, now there's a whole set of things that might be slow and might be non-deterministic. So this balance in between is interesting. Now, you use the term integration, and you also use the term unit within your course. Yeah. Can you just clarify for everybody what those two terms mean to you?
Yeah, I know there's a lot of inconsistency and debate around like unit testing, integration testing. For me, unit is an isolated unit of logic, and integration is when you have multiple units working with each other. So in a visual example, a button is a unit, but a form that has a few inputs and a button is an integration of those individual units. At least that's how I explain it to myself. I hope it makes sense.
Yeah, and I'm a little more specific about it in a way that's probably rather opinionated. I think about a unit as a single function or a single component. And when I say component, I'm talking in terms of a component like a React component or a Vue component and so on. Like I think of those as units because, well, ultimately a React component, for instance, is a function. So still, if I'm testing that one component by itself, I would call that a unit test. Would you agree with those lines?
I think mostly yes.
Okay.
It depends on what that component does. Maybe it involves a bunch of other logic. I don't know.
Well, so that's fair. So if that component, for instance, is making HTTP calls and I tested that component by itself, but it's calling a third party.
That's already an integration of your component.
Even though I'm testing one component because it's integrating with the third party. So, and this brings me to a rather divisive point that you made in your course. So let's talk about this for a second. You said always mock third-party HTTP calls. Absolutely. And that word always is the bugger here to me. Because when I read that, I thought, well, Artem, are you saying that you don't believe in end-to-end testing? Because sometimes people write end-to-end tests, and a lot of people, in fact, believe that end-to-end testing is the only test that truly gives us confidence. Because the moment we mock anything, we have slightly dialed back our confidence in the big picture. How would you respond?
I would say that it's important to know the context of when I give this advice, because any advice can probably be broken, for better or worse. But I like the very kind of good intended defaults, if you would. So mocking third-party systems is generally what you want to do, because when you're testing your application, you want to make sure your application works. Whether a third-party system works, well, it's not really up to you, right? It comes back to the question, when will it fail? And it's just such an important and powerful question to ask. Of course, you can allow third-party communications with third-party services during end-to-end tests, for example. But I really think that, and it's also a rather, I don't know, new discussion to me at least. A lot of people are asking this, like, should I be mocking network in end-to-end tests? And I say yes and no. It just gives you a different test. So if you mock all the network in an end-to-end test, well, you get an end-to-end test. It just, the ends are at the different place. The ends are in the boundaries of your app. You're testing your entire app end-to-end, which means from your framework rendering your components, to your components interacting with the DOM, to your components making requests, you just being in control of them. And it's also a viable test to have. And then you have, addition to this one, you can enable requests, for example, network requests, and suddenly you're getting end-to-end shifting where the other end is now the backend system, because now you are bringing that backend system into your test. So depending on how it works, your test will pass or not. And that's important to know, because now there's no point to test if I click a button and I see a UI component. There's a much bigger point to test what happens when the backend does something else. What happens when the backend does this particular scenario that I expect? So to me, the latter reminds more of a smoke tests, especially due to the cost. You need to communicate with actual servers, or you need to spin up maybe test servers, up to you, but it's definitely more expensive than having a network boundary and testing your basically front-end end-to-end test. But both have a place to be, and this is often what I advise people. You cover your application, and if you do that well, you actually have a single test suite where you can reuse this setup even for your smoke tests. Maybe you have a conditional, some environment variable that says, okay, now run the same test against an actual backend. And, you can play with it as much as you want.
So it sounds like you agree end-to-end tests do have their place, right?
Of course.
Okay. So give me a sense then. I know this conversation is about mocking, but before we get into mocking more, I'd like to get a sense of how you feel about end-to-end tests. So imagine that I give you an application and you see that there are no tests on it. You join this team. You agree end-to-end tests are useful. How far do you go there before you then start writing tests that are mocked? Or do you actually invert the order here and say, first I'm going to write a bunch of unit and integration tests before I even think about end-to-end tests? What is your order of operations and how do you prioritize?
For the cases when there's no, let's say, no test suites at all in the project, I often say that start with end-to-end tests that cover your critical paths. Very often for products, it's login, it's anything that has to do with authentication and, let's say, purchases. I don't know, your product probably sells something. So cover that. And in this context, you write end-to-end tests that likely involves the third-party systems as well. So basically, because you want to get confidence in your software. It's not about different levels. That ultimately doesn't matter. It's just heuristics for us to make sense of all of this. But at the end of the day, you want your product to work and you want to constantly see it working. See that green check that says you're good to go. Deploy, you save. And in that case, investing in end-to-end tests makes the most sense. Those are likely more expensive tests to write, although it's debatable with modern tools, but they give you the most value, absolutely. And once you have those 1, 2, 10 tests for this critical paths covered, and you have them running on your, CI/CD pipeline, you have this confidence, you can start expanding your test suite into integration tests and move from there.
Mm-hmm. Okay, I agree with all that. I think the great line that you run into is, yeah. And if we didn't, maybe it'd be more exciting. We could really banter here. But so far, totally aligned with you. Here's the part that gets hard for me is how far do I go with those end-to-end tests before I start writing more mocked tests? So an example of this is if I look at a project that has no tests, and frankly, this happens to me quite often as a consultant, I join a team and they realize they need help in testing. So they may have a few, but they're not even running them on CI/CD, for instance, or the tests they have, some of them are failing and they've just let them set to the side, or in many cases, just aren't any. But regardless, in these situations, I tend to start with, let's make sure that every page loads. And that's a pretty low bar. It's just, does the page load? Does the heading display? And I think most people would agree, like, that is useful. But you do get into a little bit of a gray line once you go much farther than that and start asserting, say, that happy paths are working. Because in many cases, like, you can't get very far before you need to start mocking. Like, imagine that it has a checkout process. You go, I don't want to charge a real credit card.
Yeah, exactly.
I want to run through all of this. It's also going to be quite slow. So when you think about end-to-end tests, how far would you go beyond basically, does this page load? And again, I'm talking in terms of a website in this case, a web app in this case. But how far would you go beyond a sort of a hello world? Is the heading there? Is the title what we expect?
I would definitely focus on things that would make my customers go away if it's broken. So let's say if a heading is missing, that's not a nice experience, but it's probably not a deal breaker. But if I click add to cart, or if I click play the song and it crashes, well, that's not good, right? So I focus on the things that make my product, worthy, bring value. And very often when you focus on those things, well, you would have to interact with some UI elements, right? And you tap in this territory where you have implicit assertions, which is very powerful. So if you want to add something to the cart, well, the button has to be there. You'll be writing a selector in your Cypress test or in your Playwright that says, give me that button by its role, by its name, and click on it. You don't have to assert that the button is there. It's implied because you want to click on it. And then once you click, you then check what's supposed to happen. And I completely agree that you can't go far in this kind of test without mocking because, well, if it's your system, maybe you can integrate it, let's say your backend service, but very likely you're not rolling out your own, payment provider. That would be a very tedious task. And suddenly you hit this wall anyway. Well, now what? And you bring the mocks in your test to basically isolate your test. So that's also one of the points why I think it makes sense to mock third-party requests. By third-party meaning the vendors you don't own.
Mm-hmm. Yeah, and that we should probably clarify for everyone. When I saw you emphasize that third party piece, the not ownership piece is the key, because it means that there's nothing I could do if it didn't work anyway at this point.
Yeah.
It may go down at any point. They may not. And that third party is interesting too, because I would also characterize a different team in the same company that as potentially a third party. Would you as well?
That's very interesting. Like the place where you draw this line basically again gives you different tasks. So I don't think it's either or. I think it's both. You can have a task that draws that line, and now it's the task useful for your team. And you know when it fails, you know the problem is within your team. That's the value that you want to have. You don't want to be guessing. Did it fail because Stripe is down? Did it fail because the last deployment of the backend team didn't go through? Or did it fail because I messed something up yesterday when I merged these components? And the more targeted answer you get from your test, the better is the test. And again, it's not a choice. You have one test that gives your team the confidence. Then you absolutely need to have a test that checks the integration between the teams, between the services. If you have this kind of split structure in your company, absolutely. You run those tests. You probably want to run them on some scheduled job periodically, so people know, hey, our integrations are actually working. It makes sense.
Yeah. I also want to emphasize what you said earlier. I really liked that you emphasized when we're talking about end-to-end tests that you think about what are the things that would really upset my customer if it didn't work. And I know earlier I said, make sure the heading is there, but the customer probably doesn't care as much about the heading as they care about when I click this button, does it do what I expect? Yeah. So you are absolutely right there. It's just the question of, is that thing that I'm doing there something that I can do without mocking in a deterministic way? So that's where we have to get into the nuance of it and why I mentioned the heading. I'd also emphasize, though, when we're talking about those sorts of things, my mindset in an end-to-end test is basically smoke test. And by smoke, I mean, let's just make sure that the darn thing doesn't blow up. Do you agree? Is that sort of how you think about tests that have no mocks? In other words, an end-to-end test? Those are synonyms to me.
I think that's the point. It's also how most developers approach end-to-end tests. Good. It's the whole system and all its integrations. And the point is, let me know when this blows up. But to me, that's more of a smoke test. And there's kind of two different categories, smoke and end-to-end. It's not exclusive. It's basically what's the purpose of this test, when it's supposed to fail, once again.
Got it. Okay. I don't want to belabor this, but let me see if you can draw a line, because frankly, I struggle with this. How would you draw a line between an end-to-end test and a smoke test? I find that hard because I generally think in terms of, I'm just going to smoke test this as an end-to-end. I'm going to basically focus on the happy path because I can't simulate all these different error conditions unless I mock it out.
I think I draw the line in how I rely on this test. So I'm probably not running my smoke test on every PR. That would be likely too much. Or maybe I do something even smarter and I have a smoke test that I can run on demand. Let's say some CI/CD job that only triggers when I press a button. And then I have the same test suite, maybe even expanded test suite that runs on some cron job all the time. Let's say every midnight, it lets me know my product is still there, it's functional, it's good. So to me, it's about how I consume this test. I don't know if it makes sense.
Well, that totally does. And what you bring up is a bigger issue that I find with most teams, that you end up with this wonderful problem at some point where you go, we've written so many tests that we can't practically run them for every PR. Yeah. And usually that happens when a team isn't leaning enough on mocking. I've worked with teams that there's sort of two ways that you end up here. One is you don't mock at all, at which point all your tests are very slow and they also tend to be rather brittle, and you're constantly dealing with that brittle nature and people are complaining. And often what tends to happen is people want to turn off the tests after a few months because they say they're not adding enough value. And I go, let's not throw them out. Let's talk about how to fix it. Yeah. The other thing that tends to happen is you end up in a situation where you've used, say, Cypress or Playwright to write all your tests, and they're wonderful tools, but they are not as fast as something like Vitest or Jest, for instance, because you're running a real browser. There is some overhead there. So that's another thing where choosing the line between these tools can be tricky. And I know in your course, like you're using Vitest. Now, I haven't finished your course, but later in your course, what other testing tools do you use other than Vitest?
We're not using anything later because the point here is not even about Vitest. The point is to understand when you apply different mocking techniques. Like, why do I need to mock date and time? And when? When do I need to mock a function? Or where do I need to mock the implementation of that function? Vitest is there just so we're able to run it. So it's not just drawings on the paper. We actually write code and we run test command and we have Vitest verifying that. Ultimately, the mocking techniques are the same, whether it's Vitest or Cypress, it doesn't matter. It matters when it comes to choosing these particular tools and the APIs they give you. So no, in the course, we're focusing on Vitest because it's in the name. We have mocking techniques in Vitest. They also have a few really, really cool APIs that I believe are specific to Vitest or at least improved by it. And then you can go from there and apply it anywhere you want. It works pretty well in Jest as well and in anything else too. You can even build your own mock utilities. I mean, it's up to you.
Nice. Okay. Yeah, I remember Kinsey Dodds had a course where you basically build a testing framework from scratch in his JavaScript testing course.
And we have a workshop for this as well. It's called Testing Fundamentals, and I'm teaching folks to build little Vitest there. It's directly inspired from what Kent did with testing JavaScript, and it's pretty fun.
Nice. Okay. So then, are you saying then your course at no point goes into using mock service worker?
Of course.
Oh, it does.
Yeah.
Okay.
Yeah, we have a whole section on network mocking because it's important. It's probably one of the biggest reasons why people reach out to mocking in general. Again, these third-party services. So of course I have to mention how do you mock network, and we use MSW there, and we go through 5 or 6 most common scenarios. How would you mock the network?
Okay. So let me introduce MSW then for those that haven't tried the goodness, and then you can tell me how good a job I did. I've been using MSW, which stands for Mock Service Worker, for years. I found out about it from Kinsey Dodds tweeting about it years ago. When I found out about it, I was using sort of a competitor to it called JSON Server. When I say sort of, they are very different tools. With JSON Server lets you quickly spin up a RESTful API, run it on your local machine, creates a little database, and that database is basically JSON. So it's really easy to work with, but there's some benefits with Mock Service Worker that are interesting. What Mock Service Worker does is it captures network requests so that they never leave my machine. And I can say, if a GET request to /user occurs, don't let that leave my browser. Instead, go ahead and use this mock data. So that way I could be on a plane, I could be in a tunnel, I could be in a car, or maybe the environment is down. It doesn't matter. Everything's on my local machine. My mock data applies. And I can also do things like control how fast or slow these requests are using a delay, which is really nice too. I can set up dynamic responses by reading the query string and changing the mock data that applies based on this. So Mock Service Worker, also known as MSW, that's the tool that we're talking about here. And so that's my tee up. Is that a fair summary of it?
That's absolutely fair.
Wonderful. Okay, so now that everybody has that foundation, working with Mock Service Worker has been a lot of fun for me. What are some areas that you've found that people struggle with mocking HTTP, and why is it that Mock Service Worker is such a popular choice for doing that? Because it's not the only way to do it. Why should I choose MSW instead of, well, some alternatives that we can discuss here?
I think very often teams would come to this point where they have some integration test suite that uses mocking as well. And then they have an end-to-end test suite. Maybe it has some mocking there as well. And they eventually come to the point where they kind of do the same thing. They describe the network just on different testing levels. And because they use different tools for those levels, let's say Jest and Cypress or Vitest and Playwright, well, those tools, they don't really talk to each other, and for the better, they have their own responsibility. But your wish, your desire to describe the network is just a common thing. So we embrace this idea that you actually go like network first, mock first, and you describe your behavior, and then you integrate this description, these mocks into different tools. And what's nice about it is that there's no adapters, no plugins. It just works on the environment level. So we just support 2 things, Node.js and the browser. And that's it, because this covers all the tools that exist in JavaScript, let's say, apart from custom runtimes.
Exactly. So how do you decide then? Let's talk about some competitors to it. Like one thing I could do is I could mock out HTTP using a JSON server, which I talked about before. Basically, I'm not really mocking in that case. I'm basically standing up another local alternative. So with JSON server, for instance, I could run something on localhost 3001, and then I could just change the base URL for my application, and all my requests would go to my locally hosted alternative there. You could also stand up your own mocks with Express, for instance, or you could use the mocking tools that exist within, say, Playwright or Cypress or Vitest or Jest. You could there's others out there too. I won't go through the exhaustive list, but what do you feel like is, well, let me ask this.
Uh-huh.
Do you ever use those alternatives, or as somebody who obviously mock service worker well because you've been maintaining it all this time, do you ever reach for those alternatives? And when you do, why?
I used JSON server in the past. I also used Knock in the past.
Okay.
I gave Mirage.js a try. I think like during the years I used almost everything. Some of it because
Mirage, yeah.
some of it because I was building MSW. I was just curious. How do I do this in another tool? Just out of curiosity. What is the experience? I want to find really good experience for people. And I don't really view MSW or like competing with any other tools. I don't think that's the point. We're just trying to provide different experiences for a slightly similar goal. So coming to your example, if you absolutely can use JSON server, which is fantastic. You can spawn your own server on your machine and then direct your app to that server. But I think what I kind of dislike by doing that is that, well, that requires me to change my app. So now I need to talk to this different URL. And it's not a big deal, probably. Yeah, you put in an environment variable, what is your API URL or whatever. But to me, that's a deviation that is not necessary. Because let's say I'm developing in my machine, so I run my environment variable, I point it to my local JSON server. Everything works great. Then I, merge it, deploy it, and my app is broken because the actual variable in production, let's say, has a typo or it's missing. And to me, the more of these deviations you have, the more you're kind of in a different universe, especially when it comes to mocking. So you really want to stay in the same universe, just gain control. And it's not an easy thing to do. It's almost always a trade-off, and that's why a lot of tools historically provided you value, provided you control over the network, but they also asked a lot of in return. Most common example is just taking away your request client, what people used to do with, let's say, just mocking your Axios. Such a common use case. People just do mock Axios and get method now resolves to this JSON. And you're throwing away so much from Axios because, well, first you're throwing away the whole Axios. The second, the get is just a dummy function that doesn't do anything. To me, that's quite a big deviation because your users in production will be running Axios. And the more of it you run in your tests, the more these two experiences, these two universes are the same. And that's what you want to do. You want to test in the same universe as the user. So that's one of the principles of cornerstones of MSW is to keep that universe the same. Keep your tested environment as integral as possible by not modifying your request clients, by being client agnostic, in fact, relying on the environment, and even then in such a way that doesn't disrupt the integrity of the environment. Like we're using the service worker API, which is a standard API, and you can do any request in the browser and it gets intercepted by this worker. There's no patching. The request went through. You can see it in the network. It happened. That's the point. It happened to the same URL as in production or any other service. Maybe you're communicating with GitHub or Stripe. It happens. Then the worker catches it. Then it communicates to MSW and, you get the behavior you want. So I guess for me, that's kind of the mental model that clicked over the years. And the second thing, which is even bigger, probably, but I really love the reusability of it. I don't want to repeat myself from test to test. And I don't want to repeat myself. I want to mock something in development. Like maybe I want to check some scenario. Just imagine you have a page in your app. It's not a test. And your QA engineer comes and says, well, this page doesn't work sometimes. And now you need to try, probably you have in your head, okay, maybe we receive some bad response. Maybe we don't have some permissions somewhere with the systems we're talking with. So you have some ideas. How do you try them? I I don't know. So that's where you bring MSW and you just reach to your handlers and you say, okay, this request to this third party in my browser right now, I wanted to return this. And you go through this scenario and you see what it does. That's effectively a test. This is what you're supposed to put in a test. But this accessibility of the network control is what really makes it click to me. I can reuse the same handlers. I can add any handlers while I'm working on the app. That's pretty cool.
Yes, absolutely. I want to emphasize something you said earlier, which is a common mistake that I see where people are changing their production code to support testing.
Oh, yeah.
And that's one thing that I love about Mock Service Worker is the only change that I make to my production application is to put in a little seam at the entry point so that I can dynamically enable Mock Service Worker at the entry point. That's it. Like, I should not change a single other line of code. And the moment that I do, frankly, I see this fairly often. I will set up Mock Service Worker, and then later we'll be looking at pull requests, and we'll see somebody putting if statements within the code saying, well, if mocking is turned on, do this other thing. That's a smell. And I assume you agree, right? Because Mock Service Worker is designed this way to say, when Mock Service Worker is on, all your application is going to do is continue to make those same HTTP requests to the same configured base URLs that you always had before. But the difference is you're going to get this mock data instead. And that's really powerful. I mean, I've actually looked at recently, I was doing an audit for a client, and they apparently weren't aware of Mock Service Worker. And what they had done was they had written if statements within every single HTTP call to say, if mocking is enabled, return this hard-coded JSON, otherwise this. And it was littered throughout their code. Like you're looking at production code. So all of their mocks were actually deployed to production. And those if statements, well, hopefully they don't get executed, but you've bloated all this code. You've added all this complexity. Really, like I was so excited to show them Mock Service Worker because you go, oh, you're going to love this, guys. Like we can stop shipping all of this to production.
I hope they did.
Yeah. So that's great. I'm curious then, when I work in Mock Service Worker, one of the things that I struggle with is getting teams to consistently declare their mock data, like the mock data structure, where we store it, how we name it, how we handle the different scenarios that it represents. So I'm curious, do you have any patterns that you found useful?
I think there was probably the right introduction is to say that MSW is really sort of low level. So in a sense that it doesn't make those decisions for you. It gives you just two things: the protocol to affect the network, so your request handlers, and the interception algorithm behind the hood, making those request handlers work. And everything on top of that is pretty much up to you. So you can generate fixtures, you can create dynamic scenarios, you can share some instances of anything you want between handlers. I don't have any hard opinions. You probably know better based on what your app does. But what we try to do is at least embrace some level of input of data, because a lot of people use some source of data when they test their apps. So they don't want to hard code every request, every response. So what we try to do, we introduce this library called source, and you can use it to generate handlers. So when you're using it, you basically have two options. You can provide it a network archive. So for example, you can go to your app on staging, you can record the behavior in your browser, and you can export it as an HAR file. And you can put that file next to your test, use the source library, and now you have the same behavioral network in the test every time, which is really cool. And the second option, you can provide it your specification. I'm a huge fan of specification-driven API development, and you can provide your open API specification to this library, and it will generate you the mock handlers, the request handlers as well, which you can use anywhere. Again, MSW is not limited to testing. You can use it in the browser, you can use it anywhere you want.
And where would somebody find this library?
I believe it's at source.mswgs.io, I hope. It should be.
Okay, so to be clear, it's affiliated with MSW.
Yeah, of course. It's another project in the ecosystem. So we have MSW, we have the source, we have also a data package, which is a bit underloved, but hold on, I will get to it eventually. And the point of data is that you can model the data. So when I talked about source, it's basically a library that can outsource your request handlers writing, when you don't want to write it by hand. But sometimes you just want to have a different dynamic data scenarios. And we built data for that way back in the day. And it works kind of similar to models in Mirage, if maybe folks use that. The idea is that you model the data, literally, and you can then create instances of that data. So you create a model called user, you define the fields, then you use probably Faker to create fake data, and then in your mocks you can just do user.create with this data. Or if you want to update, let's say user, if you intercept a post request or put request, then you can do user.update and you find the user by request payload and update. And data is nice that it actually has an in-memory database that keeps all those entries, and you can kind of make your mocks a little bit more alive.
Love it. Okay, so the two things I want to cover here. One was you said HAR earlier. For those that don't know, an HTTP archive file is what that is. So it effectively is a format that describes an HTTP request, right?
You know a fun fact, which I learned while working on Source. This HAR, this HAR format, it was actually never standardized. There's no standard for it.
Oh, great.
It just happened. It just happened. Browsers just shipped it, and we have this thing in the browser recording our networks, but it's kind of freeform, but people agree, thankfully.
Oh, interesting. So you're saying browsers consistently support the HAR format, HTTP archive. It works the same, but there is no specification. So it's more.
I believe there's a document. There probably is RFC drafted where the author says don't use it. Or something like this.
That's
Again,
great.
People can correct me in the comments. I remember something like this when I was researching. Is there a spec? How do I make sure my library supports HAR? And it was fun to find.
Hey, we're all out here shipping REST APIs for whatever that means too. So maybe you can live without a spec sometimes. You know, it does create a whole set of trickiness though, because you don't have this canonical reference later if anything goes sideways. So yeah. Okay. So you also brought up something else interesting there. When you talk about mock data, you had mentioned Faker, for instance. Mm-hmm. How do you think about using tools like Faker? For those that don't know, Faker, Chance, there's lots of other libraries out there, and effectively they create fake data, but that fake data is realistic. So I could tell Faker to create a credit card number or a phone number or names and so on. And it's not going to be ABC. It's going to be real names, realistic looking credit card numbers. So that way your mock data looks real. How do you decide whether to use those versus just rolling by hand?
I think Faker is really, really nice when you're working with complex requests. For example, I have friends in Apollo, and just generally people testing GraphQL. Well, very often they mock this queries or mutations that happening, and there's a bunch of fields. And sometimes you don't really want to mock all of them. Maybe you want to focus your test on a particular field, but if you drop all the other fields in the response, in your mock response, that would again be this deviation that you don't want to make. So what people often use there is they just provide mock data. One of the use cases was that, well, what if you want to test your application and you have some scalar type in GraphQL, maybe a custom scalar type, but you want to make sure that it always has some value. So again, I believe there's a GraphQL testing library right now from Apollo in the works, which is very awesome. And they do precisely that. They let you say, okay, this, I don't know, particular scalar type has a default value from Faker all the time in any operations across your test suite, which is one of the use cases. I think it's pretty nice. I don't know when else I would use Faker as a get-go. I used it quite a lot when I was like toying with a few projects, when I was writing backend, and I used Faker for like fake data on the front end. I think it's okay to use. You would probably know when you need it, because I would definitely recommend start with the easiest approach. You can hard code a response. And if you feel like, well, this gets cumbersome, okay, that's just too much boilerplate, there's always a solution that can give you, the next level of abstraction if you were okay with the coast, and then you use maybe something like a Faker.
Well, I bring it up because I have seen some people using tools like Faker and Chance to make sure that every time their tests run, they're running against different data. And that feels off to me. Now, there's a trade-off here at play, and I want to see how you feel about it. The argument that people will make to me is, I want different data every time my test runs, because from time to time, it's going to generate some piece of data that might cause a test to fail, and I might not have thought about that edge case. Like maybe it's going to generate a last name that is 42 characters, and we had never tested any last name that was longer than 30 characters. We hadn't thought about that. But the thing I don't like about this is that means that now my tests are not deterministic anymore. At any given day, I'm going to have a pull request that says, well, you can't merge that pull request because the test suite failed. And the test suite failed because the data that Faker generated for this particular run happened to hit an edge case that we hadn't considered. So how do you feel about using Faker or Chance, any of these libraries in that manner?
I believe at least how I would use them, I would always use a fixed seed.
Yes.
So I would make sure that even though I'm getting random values, they're predictable, they're deterministic. So for people who don't know, you often have some function, some API with this random libraries that allows you to freeze the randomness, sort of speaking. So you call, for example, faker.seed or something like this, and you provide it a number or something, I believe. And as long as it's the same number, it basically kicks off where the fake data starts, and you always get the same data for every call. It's actually call specific, like it's order sensitive, which is something that burnt me in the past. So it's very important to keep in mind. So it actually will go through every Faker call, and every call will receive the same data. But if you change the order of calls, you will see what I mean. And I would definitely make sure that my data is deterministic, because it doesn't make sense to me. So let's say you have a test that makes sure that you handle all sorts of names. Mm-hmm. How do you even name that test? Because to me, that just doesn't compile. What I would do is test number one, happy kind of optimistic scenario. We render username component or whatever. Test number two, we render really long surname for this user and we're still okay. The test number three, we have a user with, I don't know, just initials. And even at the test name level, you already have values. So when something fails in your CI pipeline, just looking at the test name gives you first minimal idea. That's what's wrong. Because what people would often do, they would engineer tests. Absolutely terrible idea. Automated tests is the worst place to be smart. Take your smartness into your product code, into your business layer. Go get it. Not in the tests. Tests are supposed to be clear. When they fail, they need to provide you value. And the more layers of abstraction you need to battle through to get to that value, the poorer is your test. So to me, it starts with a test title. Very short, clear description. What is this about? Then it goes to assertions. What are we actually checking? We're checking that this equals that. As little abstractions as possible, no for loops, very clear one-liner expectations. And again, if you test again against random data, there's no clarity here because data is different on every run, right? So I wouldn't advise that. I would advise using fixed seed. You can use random data maybe in like visual regression tests if you want. Frankly, quite new territory to me. Still looking forward to explore visual testing as a whole. Maybe it has a place there where you can just have a single component and it tries a bunch of different iterations and gives you, this iteration wrapped the last name to the next line and you have a regression. Maybe that makes more sense, but not your conventional integration end-to-end test.
Mm-hmm. Love it. Yeah, I agree with all of that. I also am curious though, if we pivot a bit, talk about how you implement mocking in scenarios where the data does change. So let's talk about, you've got a feature and I can say, edit a product. And I'm going to mock out that HTTP call where I edit that product. But I need to be able to assert then that mutation worked. And I might do that by, say, navigating away from that product detail and navigating back to it and then making sure that product detail is still reflected as showing the edit that I made at the beginning of the test. Mm-hmm. How do you handle mutations when you're mocking?
I think I have a rather specific view on mutations in general. We had a really nice conversation with Sanil, basically the guy behind Partikit, for those of you who don't know. And we had a nice conversation about like testing WebSocket events deterministically. But whatever, that's a context. How I like to approach this is you can think of a network mock as your boundary, as your box. And what I mean by that, you can model scenarios as those that already happened. Because if you think about this like flow, let's say I edit something on the page. Now I want to make sure it's there. You can split this expectation into multiple things. First one, when I don't know, do some interaction with my UI components and click update or save, I want this request to happen. And maybe I want to show, maybe UI shows something to the user, some pop-up, some toast notification, like it's saved. That is my checkpoint. That's what this particular flow does. So what I'm focusing on, I can interact with the page, I can enter new data, I can click save. It does the request because I have a mock for it. If I didn't, there will be an error. And then let's say it does some UI notification back. That's it. I don't test that the data persists. That's not a part of this expectation. You see what I mean? It's like you don't really have to test this whole flow, especially if you're talking about integration level testing, but you probably mean end-to-end. But even on end-to-end, I would say, well, that's all, like there are like two parts to this flow. And then when I visit the page, I need to just make sure that whatever my server responds with is in the UI. So now I split this one editing flow into two flows. My edit works and my page renders. It doesn't matter if it renders after edit, before edit, it's just one test. It renders when the backend delivers particular data. And then maybe if on save, backend delivers a different data, I create another test case that doesn't even have page, editing or any input. It just delivers the right data immediately, and then I assert on the rendering. At least that's how I approach it. If people want, they can build some in-memory data structures. As I mentioned, like we had data or have data. So they have this place that's basically a shared state in your test. So you can perform a mutation and it will actually change something in memory and then you whiz it back. To me, I don't usually rely on those tests, but it doesn't mean that there's no value in them. So
interesting. So effectively you're saying then if you're mocking the back end, you're doing an integration test in this case, you say, I feel comfortable mocking that out because really it's the backend's job to persist this. My test is just making sure that I'm making the expected call to this endpoint, and I'm going to assert that that call occurred, but it's not my job to make sure that the data was persisted to the database successfully and therefore returned back to me and is going to be shown on this other page. So you see that as more a job that might be done by an end-to-end test if you decide that you want to end to test that. Okay.
Or by a smoke test that actually does this edit, but then you need a completely different setup for it. So yeah.
That's true. Yeah. And but drawing these lines, I feel like continues to be tricky because one of the struggles that I've had in automated testing is feeling like I'm duplicating effort, where someone, for instance, goes in and writes a bunch of unit tests, and then we write some integration tests, and you start to realize that your assertions in the integration test are a lot of the same assertions that you might have been making in your unit tests. Have you seen that problem too? And how do you avoid this sort of duplicated effort problem?
I think I felt this problem sometimes, but yeah.
Okay.
I think it comes down to asking yourself, what is the point? Like, what is the purpose of this test? What are you testing here? Because very often, well, when you approach it on unit, I was actually thinking in the back of my head about this unit versus integration question from the very start. And I think maybe a better way to explain it is if you focus on behaviors. So unit is one behavior, integration is multiple behaviors. And behaviors often mean intentions that you want to cover in tests. So when you create those intentions, well, they ideally don't intersect, or at least you need to have a clear idea. Okay, now I'm testing just this behavior of this complicated component. It doesn't have to test everything that's happening here. I just want to test this one behavior. Maybe for other behaviors, I have other tests. Maybe I have unit tests for them and so forth. I usually cover all small things with unit tests, like my utilities, maybe smaller components. I focus mostly on integration tests and end-to-end tests because it's kind of more accessible recently and tools are really good and performant. And that's how I go with like the separation between the two. If some intentions do intersect, maybe I repeat my assertion. As long as it's a valuable test, well, I'm safe. Sure, maybe that's a repetition. You can go and reason maybe you should split this test and so forth, but it still brings value if I cover it correctly.
Got it. Okay. So then what are your favorite testing tools? There's a lot out there. And why are they your favorite?
I do like Vitest, obviously, but really I started using it, I think, a few years ago. and it's an amazing tool. I just love it. From the way you write the configuration to the way your tests run, and I just have this nice feeling of running something that's modern. Because I've been using Jest for a while, and I love Jest. But to be fair, it's a little bit stuck behind, and especially when it comes to supporting modern module formats like ESM. And once I switched to Vitest, it was really, really like a gust of fresh air. I don't know. It felt very nice. It was very snappy and fast for me, and I just love it. The team puts a lot of effort into designing it. They're also working on the browser mode support right now. I'm collaborating with them. They're using MSW under the hood for a bunch of interesting mocking related things.
Oh, really?
Yeah. And I really, really love what they're doing. I think the tool is amazing. And I do encourage people to try it. It's compatible with Jest for the most of it. And you can see how to do things that maybe are a little different or not compatible. I think the biggest difference between Jest, which probably most people use for integration testing, and Vitest is how they run tests. Because Vitest is isolated by default. And that's also one of the reasons why people experience some performance degradations without realizing it. And Jest is, I don't know the proper terminology, so forgive me, but it kind of runs your tests in the same thread at the same time. Whereas Vitest wraps your test suites in different threads. And there's also a nice documentation on that. You can disable it if you want, but that context isolation is very crucial. It prevents any kind of state from leaking between test suites. So that's kind of a good default, and that's another reason why I love Vitest. It's the good defaults.
Yeah, that's a great call out. I also like how Vitest just seems to be more just out of the box, less configuration is required. Yes. In fact, most cases, I don't feel like I really need to configure Vitest. It just plain works. It's funny because you could rewind. The reason Jest became popular over things like Mocha was you could just use Jest and there was no config, but the world kept moving forward, and then it was like, okay, but wait, I need to use Jest, and I have to configure Babel with Jest. I want to use TypeScript with Jest. So there's, over time, I think what you described as well, like it feels like Jest isn't getting the attention that it used to get, whereas Vitest is continuing to innovate rapidly. There's a lot of attention there, so I'm really happy with it too. So you and I not surprisingly agree there. How do you feel about in-browser testing tools like Cypress and Playwright and the alternatives?
I think they're both amazing. Okay. I used Cypress in the past quite a lot. Then I switched to Vitest. We use Vitest to test MSW in the browser, and I use Vitest for some testing of other projects, and I think it's very nice. I see them as, I don't know actually if it's still true, to be completely fair. I've been using Playwright exclusively for a couple of years, so I haven't touched Cypress, but I always saw them as Cypress more of a app testing tool, like in-browser application testing, and I saw Playwright as a browser automation tool. Playwright gives you much more control over the underlying browser and Chromium APIs. And you can do a lot of cool stuff that you can't do in Cypress, like opening a new tab or multiple tabs, accessing, service worker requests and stuff like this. So for me, Playwright was always more powerful. That was actually one of the reasons some people kind of ignored Playwright for some time, because it lacked this convenience that Cypress had with all the selectors and the ways you write the test. But then the team caught up. Now they have a lot of really nice ways to write end-to-end tests. You have this React testing library inspired selectors, get by label text and so forth, which is really nice.
Mm-hmm. Yeah, I love that they put in those React testing library. And if you go to the locators page for Playwright, that it's right at the top. We suggest using these locators. I go, yes, this is wonderful.
Those are amazing.
Yeah. In fact, that's probably my biggest critique. I'd love to see Cypress move in that direction too, and just deprecate their older APIs, update their docs, and say, like, testing library, when it came out, it was so exciting to me. I went, yes, this addresses some concerns that I've had for a long time. I want to test the way the user sees. I want to have this encouragement to write better HTML, to think about accessibility. It's just such a great API.
I do believe they have community-driven packages that have similar semantics of how you...
Oh, they do. Yeah, it's just, my concern is that if I go to Cypress, they're not pushing me in the direction of using testing library with Cypress. But anytime I use Cypress, I would use it, and I encourage my clients to as well. So yes, that's a good call out. Okay, so I know we're about out of time here, but I've got a fun one to close us out here. I'm just curious. this is a total hypothetical. People don't take it too seriously. But imagine that I said, okay, Artem, you have to choose a testing style. You can either write unit tests, integration tests, or end-to-end tests, but you can only do one style. Which style do you pick and why?
I would pick end-to-end. I find myself proficient enough. I know the tools. I can write end-to-end tests as fast as I write integration tests. And you still need to invest in the setup, so that's a separate discussion. So I would pick end-to-end tests for sure, but that's because of the familiarity. Otherwise, I would pick integration tests because that's a good balance between investment, time investment, effort investment, and the value you get.
You've actually surprised me because obviously this conversation was focused on mocking, and I was really expecting you to say either unit or integration. I figured you'd say integration, but I think you've technically answered correctly though, because the thing is, only an end-to-end test truly proves that the darn thing works. But the problem is there's a whole set of things that I can't reliably test without mocking them because I don't control all these things. And if I've got a testing suite that is either really slow because I don't control it or really flaky because I can't control it, people are going to get very frustrated. So that's why this whole conversation around mocking is so darn important. And it's also where with great power comes great responsibility. Like I emphasize to people, I love that you got this course on mocking because I really do think it's a hard problem for people. So I'd encourage people to go out, check it out. And I also would encourage people to avoid getting too sort of tied to a certain approach. I know I felt this early on when I was writing automated tests. I learned how to write unit tests. I'm like, oh, great. I'm just going to write a bunch of unit tests. And you'll see that meme of the Titanic sinking and it'll say, okay, unit tests pass. And it points to all these things. That's the problem with writing just unit tests is it doesn't tell us everything glues together right. So that's why all three of these work together. Do you feel, how do you balance it? If you were to throw out percentages between these big three, between unit, integration, and end-to-end, what do you consider a healthy balance between the three?
You know what's interesting? Like I understand that people usually talk about the testing levels in a concept in the context of applications, but I live in an open source world, and for me, all these three levels mean probably different things than they do for, let's say, product developer. Because for me, end-to-end test is pack the package, install it in a temporary directory, and run some example usage. But in any case, I still think that we are in a state where you dedicate most of your effort to integration tests, especially if you remember something like testing trophy from Can't See Dots. That is still mostly true, but I would add one more correction that over time in-browser testing became more accessible. As I mentioned, like there's a browser mode in Vitest, there's component level testing in Playwright. We are embracing in-browser component tests. This is absolutely what I will be teaching. Like, I want you to understand that you need to test your code where it's supposed to be run. Your UI components are not supposed to be run in Node.js. They're supposed to be run in the browser. And the problem was the tools were missing. As I said, at the very start of the discussion, right? You either don't know what you're doing or the tools are missing. So tools were missing. And people basically compensated by writing more integration tests. But now tools are there. They will only get better. And I do encourage people to look into those two things in Vitest and Playwright. Those are going to be the way you test your UI on integration level in the browser. It doesn't have to do with end-to-end tests just yet. So what I would do, I would probably split them like, percentages. So let's say unit tests 15%, right? We're going to do math. Then I would split the remainder almost equivalently. I would put maybe 60% for integration testing. So it gives us 75, right? And we have 25 left. That would probably be end-to-end. Or maybe 60 to 30, something like this.
Yeah, that gives me a sense of it. But integration becomes the bulk in the middle.
Yeah, I think so. That still makes sense.
Yeah, that's a lot the way I think about it too. Yeah, I like it. I'm not surprised that you and I agreed on almost everything here. Like I've followed you long enough that I think a lot of your ideas have shaped mine as well. And like people like Kinsey Dodds that have talked about it too. You and I have obviously both been influenced by him too. Well, Artem, this has been A lot of fun for me. I appreciate you coming on. But before we close, how do people find out more about you and where do they find your course?
Yeah, absolutely. You can find me on Twitter as Getanaito. I think I will post the link somewhere. You can also find me on Blue Sky, and you can find everything I do testing related at epicweb.dev. I do write a bunch of articles. They are absolutely free. Just read them. I believe that's one of the finest writing I've ever done, and some of them are really, really great when you want to make sense of testing. And of course, when it comes to the course that we discussed with Cory, you can find it at epicweb.dev/testing. And there you go through what testing is and building your own testing framework. And you can also go through mocking techniques where you will understand finally why do you need to mock. So you don't have to do that, but you probably should. And we go through why, what it does, and also all the techniques around it. Yeah.
Excellent. Artem, thanks for coming on the show. This was a pleasure.
Thank you so much for having me. Thank you.
If you enjoyed this, please click like and subscribe. That really helps. And if your team's working in React, I can help. You can find me at reactjsconsulting.com. Happy coding!